Good morning, students. So, in the Redox chapter, we will discuss. Today, we will discuss about the balancing ionic equation, as we have earlier discussed in the previous video, balancing ionic equation in the acidic medium. So, today's topic is balancing ionic equation in basic medium and types of redox reaction. So let's we at first we discuss the balancing and ionic equation in the basic medium. So write down the headline, balancing ionic equation in basic medium. Basic medium. So, what are the steps involved during the balancing ionic equation? So, write down the equation first. Chromium hydroxide plus iodate ion to form iodide and CrO4. So CrO4 minus 2. So let's we discuss the balancing this equation in basic medium. So at first in step 1, at first we put all the oxidation number in each species in the equation. So chromium OH3 plus IO3 minus I minus plus CrO4 minus 2. So here the chromium present in +3 oxidation state, oxygen as we know -2 oxidation state, and hydrogen present in +1 oxidation state. In this particular species, iodine +5 oxidation state and oxygen as we know -2 oxidation state. Here iodide is also present in minus charge, and in this particular species chromium with +6 oxidation state, oxygen with -2 oxidation state. So at first, in the first step, we put the oxidation number in each species so that we can find out which species undergoes to oxidation and which species undergoes to reduction. So let's we discuss the step 2. So in step 2, so first we see oxidation half and reduction half by finding the which charge is going to increase and which charge is going to decrease. So oxidation half. In oxidation half, we see here +3 to +6. So increasing oxidation number, we know that is known as oxidation. OH whole 3. So CrO4 minus 2 and here +6 oxidation number. In IO3 minus +5 oxidation state of this iodine goes to -1. This is reduction half. So in the second step, we find out the oxidation half reaction and reduction half reaction. In step 3, adding of electron to make up the difference. So in step 3, adding of electron to make the difference in oxidation number. So here chromium +3, OH whole 3, CrO4 plus 6 oxidation. So if we put plus 3 electron in this side, so in that way we can balance the charge present on the chromium. In case of this species IO3 minus, here the plus 5 present on the iodine, so and here the minus. So how many electrons given to this side? 6 electrons, so that both the charge becomes equal. Now step 4. In the next step, step 4. Now step 4. In step 4, balance oxygen atom by adding water molecules to the side deficient in oxygen atom. Deficient in oxygen atom. So let's see chromium trihydroxide and here chromium 2 minus. So here only 3, here oxygen is 4. So water molecules added in this side and number of electron also written in this equation. IO3 minus plus 6 electron and here I minus. So this side no oxygen atom is present. So 3 oxygen here. So 3 water molecules added to this side. Now step 5. This is step 4. Now step 5. Step 5. In step 5 we should balance hydrogen atom. Balance hydrogen atom since the medium is basic, therefore add proper number of H2O molecules, add proper number of water molecules to the side falling short of hydrogen atom. Molecules to the side falling short of hydrogen atoms and equal number of OH ion to the another side. So chromium hydroxide plus H2O and CrO4 2 minus plus 3 electron, and so we will add water molecules on this side. Simultaneously 5 OH ion on this side according to rule. In case of this IO3 minus and 6 electron and here I minus plus 3H2O, so add 6 H2O in this side and 6 OH ion in this side. In this way we can balance the hydrogen atom. The last step and the important step, step 6. Equalize the electron. Equalize the electron lost and gained. Lost and gained. By multiplying the by multi by multiplying the oxidation half reaction with 2 to balance the electron loss or gain. So CrOH का whole 3 water plus 5 OH ion and CrO4 minus 2 plus 3 electron plus 5 H2O. So here we balance the electron lost or gained by suitable stoichiometry, and IO3 minus plus 6 electron plus 6 H2O and I minus plus 3 H2O plus 6 OH ion. So 3 2 are 6 and 2 are 6, equal number of electron lost or gained becomes equal. Now write this 2 stands for all the species, chromium OH whole 3 plus 4, here is the 6 OH ion, here also 5 OH ion. So here 4 OH ion written in this side and plus IO3 minus. Now 2CrO4, 2CrO4, 2 minus plus 5H2O plus I minus. So in that way you can balance the equation in the basic medium. Do practice and do command on this. Let's discuss the type of redox reaction. Now next topic is type of redox reaction. At first, combination reaction. We all are familiar with the type of reaction. In class 10, we have already studied about it. As we know, when two species combine to form single species. For example, carbon, oxygen to form carbon dioxide. Here carbon is zero oxidation state, oxygen is also in zero oxidation state. Here carbon is plus 4 oxidation state and oxygen is minus 2 oxidation state. So see, it becomes 0 to 4. What happens? Oxidation process going on because increasing the oxidation number, and here 0 to minus 2. So here is the reduction is going on. So in this way you can find out the oxidation species, oxidized species and reduced species by knowing the number of oxidation number present on the particular species. Next we talk about the decomposition reaction. Decomposition reaction, as we know, single product decompose into its constituent by applying any electrical method, thermal decomposition, electrical decomposition, photolytic decomposition. So in this particular species, this particular, now balance the equation, hydrogen in the zero oxidation state, oxygen is also in a zero oxidation state. Here hydrogen is +1 oxidation state and oxygen in -2 oxidation state. So find out the oxidation and reduction. Simply -2 to 0 and +1 to 0. So here is the increasing oxidation number. So here is the oxidation takes place, and +1 to 0, here is the reduction takes place. Next one is displacement reaction. Displacement reaction. In displacement reaction, we know that more reactive element displaces the less reactive element from their salt solution. Suppose sodium treated with water to form sodium hydroxide and hydrogen gas release. Now see which one species undergoes to oxidation and which one species undergoes to reduction. Now balance the equation. Sodium 0 oxidation state, in water +1 and -2. Here sodium is +1, oxygen -2, hydrogen +1, and this is 0. So simply see here, this goes to 0 to +1 and +1 to 0. So this undergoes to oxidation and this undergoes to reduction simply. And if zinc deposit or dissolve in copper sulfate solution, so also displacement takes place because zinc is more reactive than copper, so it displaces copper from copper sulfate solution and product form zinc sulfate and copper. Now this is 0, and in copper sulfate it is the +2 oxidation state in copper, which displaces from this, and zinc is a +2, so it goes zinc 0 to +2 and copper +2 to 0. So +2 to 0 means reduction takes place. Here reduction takes place, and 0 to +2, here is the oxidation takes place. Increasing oxidation number is called oxidation. Decreasing oxidation number is known as a reduction. Next is a disproportionation reaction. In disproportionation reaction, any single species which undergoes to oxidation as well as reduction. This is the important reaction for your examination point of view. So let's we discuss the disproportionation reaction. Disproportionation reaction. Disproportionation reaction, the most common example is hydrogen peroxide when decomposed to form water and oxygen. Hydrogen peroxide means oxygen here in -1 oxidation state, and this is +1 oxidation state, oxygen -2, here oxygen is 0. So let's see hydrogen, the oxidation number is same in before the reaction and after the reaction, but changes seen in case of oxygen. Here oxygen in H2O2 in a +1 oxidation state, and in water it is -2 oxidation state, and oxygen in a 0 oxidation state. So simply we find out that these species undergoes to oxidation as well as reduction. Oxidation as well as reduction. So -1 to 0, -1 to 0, increasing oxidation number. So we can say that here is the oxidation takes place, and -1 to -2, -1 to -2 means decreasing oxidation number. So here is the reduction takes place. So in case of oxygen, in H2O it is -2 oxidation state, but in case of oxygen it is a 0 oxidation state. So let's we solve one example. Which of the following is not an example of redox reaction? Which of the following is not, see here, not an example of redox reaction? The first question is CuO plus H2 and it forms Cu plus H2. In case of Fe2O3 plus 3Co and it forms Fe plus 3CO2 2Fe. And third one is potassium plus fluorine to form potassium fluoride. Balance this equation 2Kf. And in the last, barium chloride, when dissolved in H2SO4, it will form barium sulfate and HCl. So students, find out the which one does not undergoes to redox reaction. Here simply see removal of H2 or O2. You can find out easily. In the case of first is undergoes redox reaction. Here is also redox reaction takes place. Here is also redox reaction takes place. But this is the assignment for you. But I will solve these questions here for your convenience. So see here. Among four, this particular is not a example of redox reaction because put the oxidation number in all the spaces. Barium with +2 oxidation state, chlorine -1 oxidation state, H2 +1, sulfur +6, oxygen -2. Here barium is also +2 oxidation state, sulfur +6, oxygen -2, hydrogen +1 and -1. See here, +2 no change takes place, -1 to -1 no change takes place, +1 to +1 no changes takes place, sulfur +6, oxygen -2, oxygen -2. So this reaction is considered as a this is not a redox reaction because there is no increasing of oxidation number or decreasing of oxidation number seen particular example. So in nutshell we can say that this is the double displacement reaction. So you can easily note down the point. Double displacement reaction is never a redox reaction. So remember it. Let's we discuss the next topic, that is redox reaction plus electrode process. In redox reaction electrode process, there is two types of redox reaction takes place. One which direct redox reaction when zinc rod is placed. Suppose this is the electrolytic cell. When zinc rod, this is the zinc rod is placed in copper sulfate solution. So there is a transfer of electron from zinc to copper and heat is evolved. In this reaction, zinc treated with copper 2+ to form zinc ion and copper as well as heat is evolved. This is the direct reaction. But in case of indirect reaction, transfer of electron takes place. Transfer of electron takes place indirectly. It is done by separating by separating the zinc metal from copper sulfate solution. Chemical energy is converted. Chemical energy is converted into electrical energy. So there is two processes involved. One is direct redox reaction. When zinc rod is placed in copper sulfate solution, there is transfer of electron from zinc to copper ion and heat is evolved, which is the direct redox reaction. But indirect redox reaction, transfer of electron takes place indirectly. It is done by separating the zinc metal from copper sulfate solution, in which chemical energy is converted into electrical energy. So for this indirect redox reaction, we will discuss about the electrochemical cell. So students, in the next video we will discuss the electrochemical cell.